the next presentation, so typically there are two critical, the carbon neutrality is something that is being talked about across the world and very, very important today. And then post the pandemic, productivity and efficiency, construction efficiency also has become sort of very, very important. So both these topics are going to be covered by our next presenter, Professor Muhammed Basheer from the United Kingdom. He'll bring in a perspective of the Institution of Civil Engineers from the UK on these two critical topics. Thank you for joining us all the way from the UK. So Professor Basheer is chair in structural engineering and the former head of School of Civil Engineering at the University of Leeds in the UK. Currently, he is president of Institute of Concrete Technology as well. Professor Basheer has been a researcher and an educationalist for nearly 40 years now. His research has also spun off two very successful university spin-outs, Amphora NDT Limited and Senginia Limited. Professor Basheer has secured research income in excess of 19 million British pounds, supervised 35 PhD to successful completion, and published nearly 400 refereed technical publications. He has received numerous awards and prizes for his contributions to research, including a Lifetime Achievement Award from Civil Engineering Research Association of Ireland and the CanMet ACI Award for his sustained contributions to the field of concrete technology. In 2012, he was elected to be a fellow of the Irish Academy of Engineering, and in 2014, he was elected to be a fellow of the Royal Academy of Education in the UK. Professor Basheer is a member of numerous ACI, RILEM, and ASTM committees, and in addition to that, is also a fellow of ICE, ISE, ACI, ICT, IAAM, and IMMM. So with that, we welcome you, Professor Basheer, once again, and look forward to listening to your very interesting presentation.
Okay. Thank you very much, sir, for the introduction and also for inviting me to give a talk at this international session. And I don't think I can match with the previous speaker. It was a fantastic talk, and as Saurabh said, possibly it's worth a keynote talk at some, some other opportunities. So it's really interesting. In a similar way, it's a challenging, part of our industry that I was actually going to deal with. And the talk is entitled A Systems Approach for Ensuring Carbon Neutral Constructions and Improving Construction Productivity. So when I was looking at the possibility of giving a talk, I gave 4 topics actually to Saurabh, and Saurabh picked up this one. And this is the one for which I haven't done much work, but I thought actually it's an interesting topic to share with the international audience. So, objective of the talk is to demonstrate how construction productivity and sustainability could be improved using a systems approach, and to introduce a range of research and innovation in construction materials and technologies which could improve construction productivity and carbon footprint. So those are the 2 objectives for this presentation. So the outline is as follows. I just want to mention about the productivity and environmental challenges in the construction industry, and justification for a systems approach to deal with challenges after that, and then brief introduction to different technological innovations which can benefit the building productivity and sustainability, and finally I will conclude with some remarks and recommendations. So first is productivity and environmental challenges in the construction industry. I just want to say this talk was actually initially prepared for 40 minutes, but then cut down to 25 minutes. Okay, so I'll hopefully finish in 25 minutes. So if you look at this graph, you can actually see the major issue with construction productivity. So global economy, so $37 per hour. And if you look at the construction sector, it is 25. There is a productivity gap of 1.63 trillion US dollars. And this is according to a report in 2017. And that gap actually can be seen. The construction sector is the blue compared to the manufacturing, the total economy. So naturally, we have a serious problem in the construction sector. And when you look at then the energy and the emissions, we see here roughly 36% of the energy use is by the building and construction sector. That's actually this here. And 39% of the energy the emissions you can actually see here is contributed by the construction sector as well. 11% of which is from manufacturing building materials and products such as steel, cement, and glass. And as you know, cement contributes to something around 8%. So all of us are actually aware of the UN declaration as well as the different countries trying to get net zero. And we are actually possibly in the right track. Maybe you can see the carbon footprint is actually coming down, and we are hoping this will actually hit by 2050 very close to zero. And in order to achieve this, what are the ways we can actually achieve it? And this is where a systems approach would be really useful. So to address both the construction productivity and the carbon agenda, we should be able to use a systems approach. Why am I saying this? And the reason why I'm saying this is because Institution of Civil Engineers published a report recently, and it is actually a systems approach to infrastructure delivery. And when you read through that report, you will see, how the construction productivity can be improved, how the carbon agenda can be addressed. All of these are actually, dealt with in this report really nicely. So I thought it is important when you like this, introduce this report so that you can actually look at this and then see how each of the sectors where you're working could benefit from this particular report. So in the systems approach to infrastructure delivery, there are 4 fundamental principles to look at. The systems thinking is first, systems engineering is the second, systems integration is the third, and the fourth one is the extended system. So systems thinking embraces the idea that the whole is more important than the sum of its parts. In construction sector, this is a major problem, as you know. Each construction delivery team will be looking at their own particular aspects. So what we need is actually bring them all together and consider the whole system, understanding of how all of the component parts of a project work together to meet a common objective. Okay, so that is systems thinking. And systems engineering is the application of systems thinking to engineering design and management. It helps different teams working on individual component of project to stay aligned to a common goal. Okay, I'll just elaborate on some of these aspects. Then systems integration is the practical task of bringing together all of the components and taking them into service as a single fully functional system. Thus, finally, the extended system refers to the socio-political environment in which a project is to be delivered and the many, often hundreds of stakeholders who can influence it. In a project like what you mentioned, you can see how the different stakeholders can come together to enable the improvement of construction productivity and the carbon agenda, addressing the carbon agenda. So there are 8 strategic principles given in this particular report, and the objective is to focus on the, overcome the challenges, embrace technology, and deliver better outcomes, okay? So the strategic principles are: think outcome, not edifices; close the gap; owners must own the projects; future-proof projects; think shovel-worthy, not shovel-ready; bake in systems thinking; agile leadership; and data oils your project. So in this particular report, each of these aspects is very elaborately covered. So anybody is interested can actually look at these concepts, okay? So a systems approach will transfer how we will conceive, plan, deliver, and operate a project. So it's a holistic concept of a project rather than looking at it in parts. And when you do that, you achieve the productivity and the carbon agenda for a particular project. So in the UK, this particular systems approach was used in many projects, and some of them are listed here. These case studies are also mentioned in the report which I mentioned. Okay, so if somebody is interested to see how the systems approach was applied in different projects, you can actually see it. So one is the Tideway project. The second one is the British Antarctic Survey's Infrastructure Modernization Program. And the Crossrail is the third one. East-West Rail is the fourth one. The Anglian Water Strategic Pipeline Alliance is the fifth one. Constraints the systems approach capability is the sixth one. So you can actually see in different sectors the systems approach was applied in the UK, and they concluded based on the assessment that the systems approach benefits both construction productivity as well as in reducing the carbon footprint. The cross-cutting lessons learned from these projects are: keep the end in mind throughout the project. Ensure we really are all in this together. So that is, all stakeholders should work together, okay, with a common objective. Think hard about the leadership. Who should actually be leading the project? And do you have to deliver all at once? The way of the project to be managed for the delivery, that is to be actually planned in such a way that all of these concepts can be applied. So the principal lesson from all of these case studies is that the construction's traditional heroic style of leadership is not fit for purpose for modern projects. The sector needs to adopt leadership models that spread authority and empower highly competent individuals. So that is one takeaway message from all these projects. So this report, I'm actually not introducing the report in full, okay? So the principle of the report you can actually download and then read it. I think it is freely available. So I'm just sort of introducing those. And in our industry, some of the technological developments have been taking place, and we can actually see how the technological developments and innovations are contributing to the systems thinking. So just a few minutes I will spend on that, okay? So the first one is the low carbon concrete route map. So institutional civil engineers also developed this carbon concrete route map. So it's not a road map, it's a route map. So there are definite strategies in that route map for achieving carbon neutrality of the construction. And the goal is to achieve net zero concrete by 2050. And the strategic focus areas are: reduce the amount of concrete and rebar used, reduce the carbon intensity of concrete and rebar, and sequester or offset the residual carbon. So this report gives systematic way of addressing the carbon agenda. And in fact, recently, the government of the UK has announced some net zero carbon strategy, and they have taken into account this report. And this is actually an important report for considering the net zero carbon agenda. And in here, there are some fundamental things to consider. And the strategies for reducing embodied carbon are reduction strategies are carbon benchmarking, improvements in how we use concrete, improvements in how we make concrete, ultimately leading to net zero. So in here you can actually see the 50% probability of limiting the warming to 1.5 degrees Celsius, and 66 probability of limiting warming to 1.5 degrees Celsius, and the critical period is until 2035. So government of UK strategy recently announced is to focus on this particular period until 2035 to ensure that we are on the right track for carbon, achieving the net zero carbon. Okay, so as I said, I'm not presenting all the details of any of these reports. I just wanted to introduce these concepts so that you can actually see what is going on in some other countries in terms of addressing the carbon agenda. So obviously, when you think of carbon agenda, the circularity of the economy can be an important aspect to consider. And it will reduce the waste, it will drive greater resource productivity, it will deliver a more competitive economy, it will position to better address emerging resource security or scarcity issues in the future, and also it will help reduce the environmental impact of our production and consumption. So the circularity concept definitely needs to come in our construction industry. And some of the developments already taking place or that can be applied are precasting and 3D printing. So here is an example of the precast concrete bridge. So you can see a flat pack system brought to the site, and within a day, this kind of bridge can be constructed. So just to finish it, within 2-3 days, the bridge is all finished. So it is making use of precast concrete blocks being brought to the site, lift them, put them in. As mentioned, successfully bridges up to spans of 18 meters were constructed. It's very high, cost effective and durable. In terms of the material used itself, you can actually try different carbon neutral materials, and thereby some of the carbon agenda can be addressed. And instrumented bridges facilitate performance monitoring in service. So the whole life concept can be brought in, and we can actually design for life cycle, the total life cycle cost, and we can monitor the performance, and we can see how the bridge is performing. Okay, so this concept is actually one way of addressing the issue. This particular one is the finished small bridge constructed. Okay, so this was a technology patented by my PhD supervisor, Professor Adrian Long, and it's now marketed by a company in Northern Ireland called Macrete. So, what are the facilitating factors for use of more precast in the industry? So as shown, you can obviously have buildings as well as bridges. The high strength and high performance concrete is one of the reasons why precast can become part of the agenda. Advances in admixture technology is the second one. Advances in the fiber reinforced concrete is the third one. Advances in pre-stressed concrete is the next one. Advances in structural connections is the other one. Better skilled construction workforce now. The ASA has this certification program. So concrete technicians working on the field could get actually could be trained by this kind of certification programs, and thereby the quality of the workforce can be improved. And when you have qualified people working, that will improve the construction productivity. And introduce the whole life cost and life cycle analysis, and better awareness or concern of the sustainability. So all of these will or are facilitating things for the use of precasting in our industry. And then comes the 3D printing. I've shown two pictures here. And as you know, one of the largest building was printed in 2019 in Dubai, and this is from here in in US. And the social housing is actually becoming a common thing that is being printed in Texas. As far as I know, there was a BBC program recently which I saw giving examples of how the 3D printing is used by the US house construction sector. Okay, so the facilitating factors there are advances in material technologies, building information models, construction robotics, artificial intelligence, and construction informatics. All of them are actually working together in helping this type of modern technologies being used by our industry. The features are the structure is built directly on site and could use local materials. It's efficient in insulation to reduce energy consumption as well. Okay, so if you compare then the traditional concrete manufacturing procedure with 3D printing, some of the advantages are free from formwork, less labor, saving in construction time, better working environment, less construction waste, reducing risk of construction, reducing energy consumption, and reducing the cost. So there are so many advantages, and which means that we need to be focusing more and more on this type of construction technologies for advancing our, the industry. And when we do that, productivity improves, the carbon footprint goes down. So I'm happy to see many people focusing on the use of different types of cementitious materials, but please remember, all what you can save is 8% of the carbon footprint, but the industry itself, is 39%. And in order to do that, other means of reducing carbon footprint has to be resorted to, and these are some of the technologies. And construction robotics, artificial intelligence, and construction informatics I mentioned. So here, it's a 3D printed, so it's a bridge in Amsterdam, first robot printed steel bridge, and it's taken from Arab Journal. So the developments in artificial intelligence and the machine learning, all of these are actually helping us now to bring in this type of concept for different types of constructions, not necessarily just only small things, and larger constructions as well. And construction robotics is another field. You can actually see here the drivers are high level of construction and growth expansion activities, unsafe environment, injuries to labor, and things like COVID-19 pandemic, and the uncertainties associated with them. So we can make use of construction robotics in such cases and thereby improve the construction productivity. So typical construction activities using robotics are structural demolition, bricklaying, assembling prefabricated components, welding arms, construction of road pavements, unlocking of design possibilities, aerial surveys. So many different applications we can actually make use of construction robotics. So more research needs to go in there so that we can develop this area also further. And this is an example. It's called virtual sieve analysis. So image-based system is used for grading the aggregate, which means that from the information you gathered, you can decide how much of a cementitious material to be used. So rather than predefined amount of cementitious materials, depending on the material you use in the conveyor belt, you just simply take the picture using images and then use the image analysis to decide the sample size distribution, and then you can actually find out how much material to be used. So rather than using so much of cementitious materials, this will help in reducing the amount of cementitious materials used. Okay, this was a work which we did some time back, and we have what should I say, this technology was patented as well. And another one is the use of structural health monitoring. This has been actually becoming a popular one, but in terms of the SHM, that can be used for whole life management of infrastructure. And people have started using it. And the benefit of that is, you can see, structures usually will follow this type of thing. And if it is nuclear containment structures, you will design it for the whole of the intended service life. But most of the structures will have a certain level of deterioration, and then when it hits a minimum acceptable level, you'll intervene and repair it. So that's the type of thing. So if you have sensors, you can detect the problems early, and the timely intervention and management of infrastructure is possible. And here we have actually an example where during the construction of the Hanjibei Bridge in China, sensors were introduced, and these were actually used for monitoring the performance of the bridge. And different types of sensors were used, both fiber optics and electrical sensors. They can measure properties like temperature, RH, pH, chloride strain, moisture movement, chloride increase, carbonation, corrosion. So a combination of environmental features as well as the mechanisms of deterioration of the material itself, you will be able to monitor, and that information can be then used for predicting the service life, and that way we will see how best we can manage these structures. And the data, in fact, can be collected from the office itself. There is no need for us to go to the site, and once you have the data, you can use service life modeling techniques to predict the service life. And as you know, if you are a member of Committee 444, you know that there are, 365, not 444, 365 committee, and you know that there are different service life models for fresh state and hardened state, and using those, you can predict the service life. So, in a nutshell, basically what I'm saying is, to improve the sustainability and productivity of constructions, different stakeholders should come together, and there is the need for engineers, scientists, government organizations, industries, and the society at large to work together, consider the project as one entity rather than separating into different parts, and work together. So bring together the relevant stakeholders responsible for sustainable and productive constructions, and build on this to develop practical approaches to deal with sustainability and productivity. And in order to do that, the systems approach can be used. And just to remind us that it has these 8 basic principles, and the objective is to transform how we conceive a project, how we plan the way the construction is done, the project is completed, how we deliver, and how we operate. All of these aspects are given, and when you do that, the systems approach will improve the productivity and sustainability of civil infrastructure. So, if you want to actually know more about the systems approach itself, as I said, the best thing is actually to download this ICE report. It has detailed information of how the systems approach can be applied to different projects. Okay, so this is kind of an intro type of talk rather than going into the detail. But as you can see, when you bring in different concepts together, both productivity and sustainability can be addressed together, and thereby our industry can achieve the agenda of net zero. Thank you.